I merge code that Claude Code writes without reading all.
So even if a function secretly hits an API
So suspicious behavior surfaces itself.
Jacquard isn't asking, can you trust it?
Renka, I've got something I'm a little guilty about lately.
What's this out of nowhere?
I merge code that Claude Code writes without reading all of it.
Yeah, that's pretty normal. Honestly, I think everyone does that. They just don't admit it.
But I have no idea if it's hitting a network somewhere behind the scenes, or writing to files. I just go it runs, so it's fine. But I don't actually know if it's fine.
That's a problem getting a lot of attention right now. Reading every single line of a AI-generated code just isn't realistic.
No way. It spits out hundreds of lines sometimes.
So an interesting language showed up as a solution to that. It's called Jacquard.
Jacquard? I don't think I've heard of it.
It's a research project that just hit show HN last week. With this language, you just look at a function's signature. You can tell instantly whether it touches the network. You can also tell whether it touches a file.
Just from the signature, you don't need to read the actual code.
Right. What it touches gets baked into the type, so it's forced to show. There's no hiding it. Let's think about this with a Python function as an example. Say there's a function called normalizeName. It takes name as an argument and returns text.
A pretty typical string processing function.
This function calls another function inside it, called lookupAlias. And that lookupAlias hits an external API.
There's no way you'd know that from the signature.
Exactly. You can't tell whether it touches the network unless you trace the implementation one level at a time. With human-written code, there's this trust of that person wrote it, so it's fine.
If a senior on the team wrote it, I'd probably trust it.
But with AI-written code, that trust just isn't there.
So AI is basically a new hire you're meeting for the first time, every single time.
And a new hire who dumps hundreds of lines on you all at once. There's too much to read through. And even if you do, side effects are easy to miss.
So we need a language where you can spot side effects just by looking at the types.
In Jacquard, an effect tag is forced onto the function's arrow. For that normalizeName example from before, you'd have to write it like this. normalizeName, text, net, text.
There's a net next to the arrow. Is that the effect?
Right? It means this function might touch the network. If it touches a file, it's fs. If it prints to the console, it's console, that kind of thing.
So if a function has multiple side effects, you write both.
Yeah, you'd line them up with a comma, like net fs. And here's the important part. Forget to add it, and you get a type error.
So it won't even compile.
The checker traces every effect from every function it calls, and computes it automatically. So even if a function secretly hits an API somewhere inside, net is guaranteed to show up in the signature.
So there's no way to hide it. For review, you'd only need to check that first line.
Jacquard isn't actually the first to come up with this idea. Languages like Unison and Koka already had similar mechanisms before it.
So Jacquard is redesigning that for the AI era.
I mentioned that types tell you the effects, but Jacquard actually takes it one step further. At runtime too, it won't run unless permissions are explicitly granted.
So even if it compiles, it can still stop at runtime.
Right. So say there's code that calls a function tagged with net.
Same idea as Deno. That one also can't touch anything by default.
Exactly. For file operations you'd pass allow fs, or both if you need both. This is what really helps when you're trying out AI-generated code.
Like, run it with 0 permissions first.
Right? You run the AI-generated code with 0 permissions first. If there's an unexpected network access attempt, it stops right there and tells you.
So suspicious behavior surfaces itself, even without reading everything.
Where you grant permissions gets controlled in detail through a mechanism called a handler, like using the real network in production, but swapping in a mock for tests. That word handler came up earlier, and I think that's actually the most interesting part of Jacquard.
The thing that swaps out how an effect actually runs, right?
Right? An effect declares what to do, and the handler decides how it's actually done. So say you've got an effect called net. In production, you'd use a handler that sends a real HTTP request. In tests, you swap it for a handler that just returns a pre-recorded response.
And you don't have to change anything in the code itself.
Nope, you just swap the handler, and the same code runs in a different world.
Kind of like DI, injecting a dependency from outside?
DI is close, sure, but handlers are way more powerful than that. You can pause execution partway through, try out multiple branches, even simulate probabilistic behavior. Stuff you normally can't do with DI. A handler can pull off.
Being able to replay tests without actually hitting the LPI. That's pretty great.
There's a test framework called Warp, and it's got replay and caching built right in. And on top of that, Jacquard inherited a content address design from Unison.
That's the thing where it hashes the actual code contents, right? How does that relate to testing?
Rename a variable, reformat the code, the hash doesn't change. So even after refactoring, your test cache still holds.
So no more I just renamed one thing, and now the whole CI run has to redo everything.
I was talking about handlers, but this same mechanism works for probabilistic programming too.
Probabilistic programming, like the machine learning, Bayesian inference stuff.
Right, you write probabilistic choices as code, and an inference algorithm solves them. In Jacquard, sample and observe are defined as effects, and the inference algorithm becomes the handler for them.
Same structure as the networking example.
Exactly. Net, FS, probability. All of it is unified under the same effect mechanism, and that pairs well with AI agents, because you can express choice as a probabilistic model.
So you mean representing an agent's decision-making, which action to pick as probabilities?
Right, and once you swap the handler, simulation and production both run the same code.
Though it says right now it only supports finite discrete distributions.
Yeah, continuous distributions aren't supported yet. It's still a research stage project.
This all sounds great so far, but people must be pushing back too, right?
The show HN thread has some pretty harsh comments lined up. The sharpest one is that Jacquard doesn't exist in any LLM's training data.
Ah, well, it's a brand new language, so that's kind of expected.
Java and C were trained on decades of code. That advantage is decisive, they said.
Ironic that a language built for I can't actually be written by a I.
The author replied on the show HN post telling people to have their agent read skill.md. It's a guide for AI agents that compresses the whole language spec into a single file.
So basically, feed the whole spec into the prompt along with it.
There's also a lot of pushback that it's not clear how this differs from existing effect languages. Like, why not just use Koka, Flix, or Mercury?
Fair, algebraic effects aren't exactly a new concept.
And the kicker was that the README itself had an AI-generated inconsistency. A list the README claimed was included turned out not to actually exist.
So he built a language meant to be easy for humans to review, and didn't review his own README.
The author, J.B. Winters, actually published a file called limits.md.
He wrote down the limitations himself.
Yeah, at version 0.1, he's upfront about what it can't do and what isn't even a goal. First off, the runtime is single-threaded.
No parallel processing, huh? Not great for something like a web server.
There's also no package manager for the language.
So no dependency management system, like NPM has.
And permissions are granted per effect, not per path. Pass allow fs, and you get access to every file.
Deno lets you scope permissions to a specific directory, so this isn't nearly as fine-grained.
No security audit yet either. He says himself, don't use this in production.
Honestly, being that upfront about it as a research project earns some goodwill.
There's a lot of criticism, but I think the idea itself has real value.
You mean the whole no training data or existing languages are good enough argument?
Right? But think about the reality here. The amount of code AI agents write has completely outpaced what humans can review.
Writing speed goes up, but reading speed stays the same.
That's exactly when it helps to see, right in the first line of a signature. This one touches the network. With explicit effects, you can actually triage your reviews.
So you skim the functions with no side effects and scrutinize only the ones tagged with net or fs.
Even if Jacquard itself never catches on, it still matters if this design philosophy spreads.
Like, other languages start adopting effects too.
Koka and Unison leaned more academic, but Jacquard framed it around a practical context, AI review. It might end up being the first real practical test case for algebraic effects.
So the value isn't really the language itself, it's the question it raises. I mean, whether you can trust code and I wrote, that's never going to have a final answer.
That's exactly the shift in thinking here. Jacquard isn't asking can you trust it or not. It builds a mechanism into the language for running it safely, even if you don't.
So you design it assuming you can't trust the code.
Effects are visible in the signature. Nothing runs without permission. Handlers let you swap out the world it runs in. All of that is designed to guarantee safety, without ever needing to trust the code.
It's just frustrating that it's not a language I can actually use today.
Yeah, it's a 0.1 research prototype, but the question itself is worth asking. There's a real future where TypeScript or Rust ends up with explicit effects too.
Honestly, I'd be happiest if a mainstream language just absorbed the idea.
If you're curious, go check out jbwinters/Jacquard lang on GitHub.
Starting tomorrow, Sharina's going to actually read function signatures for once.